So hello and welcome to my talk. I'm gonna be talking about this, but like in a nutshell, it's too much text. In general, I'm gonna just be talking about alternatives to DBT, or if you want to build your custom, Lineage tool, which for which I use one of the libraries. So don't focus much on the full text. Focus on the last lines, because those are the tools that I'll be talking about. So this is me, not the Santa one, the other one with the glasses. Currently, I'm working as a head of data at MediaTek, hiring people, so I'm going to use this time as well, for quickly say that we're hiring a senior data engineer. So feel free to ping me or catch me afterwards. Also, I'm known as Uncle Data. That's another fun feat. And if you actually follow on the Spotify, you might see some interesting podcast episodes popping up in the upcoming 2 weeks, where I had some podcasts with keynote speakers. So it's not the time for me to talk about myself. I'm here to talk about things what I came here to. So first, disclaimers. I have no affiliation with Nord Tobico, which is actually the creator of SQLMesh or SQLGlot. Nothing to do with DBT. Everything is purely from my experience. So because of that, I might have missed some points. I made mistakes, and I guess it's okay, So point them out if you see. It would be a good learning opportunity for me as well. Quickly over the agenda is, why you should care about what I'm talking about. Quick intro to DBT. By the way, question, how many of you know what's DBT? How many of you are using it in production? Okay, so after, from 2/3 of you knowing it, in production users like maybe half. Now another thing, who's using DBT Cloud? Okay, so I assume the other part is using DBT Core? Yay, okay, so I guess I'm gonna run short on the intro to DBT. We're gonna talk about what's SQLGlot, why it actually matters to talk about it first before we talk about SQLMesh, and we're gonna do short comparison and maybe summary, for you to take some things out of this presentation. So, why you should care what I'm talking about. In the world of data, what matters is what's the source and what might actually, create some poor data or garbage in, garbage out. I'm using polite language here. So, if you have garbage, doesn't matter what you do with it, you still get garbage. What it does, even if you're running on a bigger scale, if you have nice data, right? Like even part of garbage goes in, your data is becoming a bit more garbage. So because of that, important thing is data lineage, because it allows you to traverse and understand from where your crappy data came in and what caused, some poor records, poor format, missing values or whatnot. So I already talked about DBT, so fast reminder, basically they're kind of known as de facto transformation tool in the data area. And what they say that, when you load the data into some database or some data store, you can run some SQL on top of that existing engine using their provided framework that's actually SQL with Jinja. So basically, SQL with steroids. I guess, like that's not the important part, and that's not the reason why I'm talking about this, right? So is there something else worth looking at? When I started to look for opportunities or like ideas, what I can check, at that point there were 3 main tools. First one was, of course, DBT, right, in general. Major player, I guess it has the majority of the usages in general. Then there was SQLMesh, which was coming as a front runner for that and contender. And there was SDF. Who knows what is SDF or heard about it? It was something, yeah, so based on 2 or 3 hands, raised, not many know. And that's one of the reasons why I guess it didn't go through well. But it was a good alternative, and I'm gonna cover what happened to SDF at the very end and why it's actually important and how it actually changed my whole approach to this presentation. So that's the important key point. So like I mentioned, important cornerstone of SQLMesh is SQLGlot. So I guess you were SQLGlot is Long story short, it's an engine. It can parse your queries. It can transpile from one dialect to another. I'll explain, of course, later why. And basically, it can, use to format SQL. It can optimize your queries based on a set of rules. It can do a lot of things. But most importantly, why I liked it is that it uses AST. But, why I'm talking and why I actually should care about SQLGlot. These are the companies. The asterisk one about rumors is the most important one because I guess everyone knows about it, but no one openly says it. There was actually one post yesterday on LinkedIn about this from the creators of SQLGlot, but it was kind of taken down like 40 minutes in. So most likely no one saw it. Then yeah, I used the source, I'm lazy. For this I used this, but I assume, that's kind of okay. And if you were in the morning keynote, that was actually the important part, and why I was so happy, that I might not need to explain anything because it was in a very good detail and very good abstraction. Explain what it is, what it does. So, important thing about abstract syntax tree. Here's a quick reminder, but in general, it's like abstracted like independently from the language or dialect what you're using. It can have like multiple use cases, right? Code analysis for the same type. You can add it for the type checking, static analysis, example from the morning's keynote, and so on. In this scenario, for SQL, you might ask, so it was shown for Python, how does it work with SQL, right? Like, so technically it doesn't matter. What's the language? It still falls to the same basic principles. This is super simple example, right? We're selecting two columns from single table with some filtering. So if I actually parse this thing with SQLGlot, and SQLGlot has like, so-called method parse1, it takes as an argument, your SQL query, and you can print out the AST out of it. So recap from the morning's keynote, this simple query creates this kind of abstract syntax tree. In this case, it's quite straightforward, right? You can see, that one node is select. You see that it has expressions. Those expressions are, columns. You can understand which are columns. If there would be, some comments, actually, by default, AST wouldn't actually parse them, but SQLGlot added this option because comments are actually important, especially in complex business logic. So you can actually see them as well, and everything else is here. So from simple query, you actually have like quite a big object, right? So now, when we look here, we don't care about the language or like the SQL dialect, what's here. It can be DuckDB, it can be Snowflake, it can be Spark SQL, doesn't matter, right? One thing what changes from the language to the language is some internal methods. So let's say date trunc, right? Everyone knows, right? There are problems with date trunc, right? Not all of the dialects actually support it. So, fun thing and how SQLGlot actually handles this is that it has this abstract syntax tree which doesn't correspond to any dialect. It goes to the raw basics, abstracted way. And internally, they have all of these kind of methods mapped out to relevant dialects. So you can actually write your query for, I don't know, DuckDB, which is quite a topic today, and then you can transpile it to BigQuery. So talking about transpilations, just because of AST, we can do this very, very seamlessly because you just have like a simple mapping, right? Date trunc goes to, cast as date or something like that, and you're good, right? You can also, do very neat migrations, right? Because who likes to rewrite queries and check what works or not from one dialect to another? I guess no one, right? Because that's the boring part and very, very error prone because it's, very human involved. And it's a tedious task. No one wants to do that. So now I talked about, internals of SQLGlot and how it actually works with SQLMesh. So SQLMesh is an alternative of DBT. Now, if you would go, to their page, you would see something fancy like this, but just like a selling point, maybe for the like management. For people, who are working with data, this slide is a bit more interesting. You can see, what it actually does. You can see impact analysis, it has unit test. Unit test, by the way, was supported, I think, from the early version of SQLMesh, and looking at DBT, it was from version 1.8, something like that. You can do same transformations, and you can do your data tests, which are called here audits. So, why? How does it look like? If you have used DBT Cloud, it has very, very similar layout. So you can see, on the left side, you have some folders, you have your models open, you have some fancy things going on where you can, you plan your models, you can view them, you can also check the lineage. If you look closely, you can see that it actually has some lineage like directly shown very, very closely or like very similarly to DBT Cloud. And it's interactive. If you click one, you get the full experience. This is running completely on my local machine, so you don't need anything fancy, and it's interactive. So I guess, if you're familiar with DBT docs, it's a bit different. And this is the outline of columnar lineage. You can see which column goes from where and why it's important. Now, right, when I mentioned, crap in, crap out, you actually want to know which column actually made your code worse, or from where it's missing, if you want to delete some column, or anything like life-changing from the data side, right? So this allows you to get everything and see everything what matters, and actually do reasonable actions to prevent prod from breaking. So, let's do apples to apples instead of apples to oranges. Very simply, let's start with model definition. By default, DBT has two files, right? Like if we're like looking, at the most level, granular level. So we have one where we have SQL file, which is, like Jinja templated SQL file. Then we have the YAML file, right? You can do, of course, instead of having a single YAML per model, you can bash them to, one huge model, but it's a bit hard to read and not efficient. Now, if you want to do some changes to your SQL code, you have to open the YAML and you have to do changes there. For me, I'm usually lazy or like forgetting to add this. So I'm super happy, that in SQLMesh, everything is added at the top of your model. So you don't have to, distract yourself, or in some cases, open the wrong model because one had like, I don't know, model and models, plural versus singular. So in this case, you're for sure aware that what you're updating is actually, the right place. Testing, right? If you have done DBT testing, and here I'm talking about data testing, not about unit testing here, just because, it's quite fresh feature on DBT side, so I don't want to bash on some things that might not be completely okay or like might not be completely solved. So let's do data test. This is an example of very simple, YAML definition of your test. You have, like DBT utils, some expressions, and after each column you add, data tests. Maybe, you have accepted values or something else. Like I mentioned, in the model definition, all the audits and data tests are going to the same file. So actually, you can see, your audits in the single place. So you can see how many of them are adding. And there I had some fun trying some different things. Basically going crazy in a way, just to see how it works and how it handles different things. Added some docs for me as well. I don't think I added this and double check, but if I'm not mistaken, inline comments also are added to the documentation as well. So if you choose, to go that way, it also works. Okay, so differences. How many of you are checking on differences when you're developing your code? So fun thing, SQLMesh, like looking at DBT, we have DBT run, right? And we have DBT test. You don't have many options, right? You run, and if it's running, you're kind of screwed. Either you drop it mid-process or you wait until it's finished. With SQLMesh, like in Terraform, you run SQLMesh plan. So what it does, it actually prints out you the differences. What's changed, and if there are fundamental changes that would require your data to be rebuilt. So if you look here, right, the changes, is like, it's updated, and what we added is only the audits, right? So we added some tests. It's actually not a breaking change, right? We can add some tests, if the tests are failing, we need to fix the test or fix the date. But if you accidentally introduce some breaking changes, let's say you, like in this example, oh, let's drop a column. What's gonna happen? It it easily, oh, okay, you changed it, you dropped a column. We see that downstream we have some changes, and you probably would like to refresh them, right? So if you would look, it allows you, to press or write yes to do an automatic backfill for all the affected models. So why it's good? In dbt you would have to run specifically that model to see if it runs, if it's okay, and figure out which models are affected. This is doing it automatically. And what happens if my change is a breaking one, right? Like I dropped a column, right? I might affect something in production in the further down models. What does it do? If you can see, what happens is doing a couple of things. So it's updating physical layer. Then, it says that it's updated the physical layer. I'm going to explain about those as well. Then, executing model in batches, basically processing your data. And, notice, yeah, dude, you dropped the column, but you're using it in another model. So what happens? If we do something like this in dbt, so what it would do? First table, which we actually recreated, it would already exist without the column, right? So that means if you haven't thoroughly checked or tested your data, tomorrow when your model runs, what you will get? A big fat error. Right? It's annoying, and oh, sorry, I missed this error, right? It's annoying, and it's like we can prevent it. How it goes, that if you can see, this is the physical layer. A bit redundant in a way, but actually helps you and prevents you from doing such mistakes and allows you, to do a bit cleaner development routine, I would say. So what it does, it actually creates a new version, like a physical table in a separate schema. If you would see, the schema name is SQLMesh Marts, where it actually stores different versions of your code, where it did some change, you reprocess something and whatnot. And there is a virtual layer. So you would see that its schema name is Marts, right? And then you have views. So now you might ask, so why views? What's happening? Yeah, the fun part is that all of the metadata, what's relevant or defined in your model, is also pushed down to the database. It actually supports that. But moving forward, what's with the virtual layer? So as you can see, it chooses the right physical model, which actually had succeeded, to run successfully. It's good. So in this case, you just got, your model is crap, fix it. We're not gonna push it to production until you fix it. So it's still gonna point to the older one, which is not broken. So that's the benefit of it. And I guess most and fun part for me is SQLMesh has DB for a state. Now, I guess, this is the most familiar things for people working with dbt, right? If you have an incremental model, that's how we usually solve it, right? How many of you are using parameters or variables, so-called, in dbt to do periodic refreshes or specific periods? 5 to 10 people. So problem with this, right? If you're not using, variables as a period, your pipelines are not idempotent. The biggest problem with this, if for accident you actually missed a day or something like that happened, you created a gap in your data. If you have a gap in your data, you then have to reprocess the data, right? Using this approach, you have to do some manual changes, do some hacks, to delete, insert something. It's a bit annoying. And as well, if you want to use variables, you have to pass them from somewhere, right? So either it's airflow variables or macros that you're using, DS, date interval start, date interval end, something like that. Fun part, SQLMesh. I'm super excited, but the thing is, it has all the information about your periods. So you have incremental refreshes or something like that. It will add information if that period has successfully run or not, what's missing, and you can do backfills very easily. But additional thing, you can see, if it's a not breaking change, you can actually push forward, with this. You can, run locally. You can add different things like, you would do in dbt. And, you can see, that at the bottom, it actually adds as well a where filter. So nothing fancy, but you don't have to track it. Now, for state, additional overhead, what it adds is actually that you have to have additional database, because in that database you have to store the state with which it communicates and get the information about periods, what's missing, what's not. So, I talked a lot. So to DBT or not to DBT? I guess that's the question. And like always answer with anything in data, it depends. So I guess if you have actually participated in my talk 2 years ago where I talked about Dagster and Airflow, like exactly the same thing goes. It depends what you're aiming to solve, what's your approaches, and your team skill set. So let's say with DBT, the biggest advantage is its community, and it's actually quite mature, right? You have everything, majority of the orchestrators working with it very smoothly. With SQLMesh, it's a bit like, let's say, shaky. Dagster is not quite there. There is some community version of the library that adds you this and so on. So it depends, because it kind of requires you to use a bit different approaches and different work with your data. Just because, like I mentioned, with the physical layer, you have to think a bit differently. Same like with your switch from Airflow and Dagster. And like I mentioned about SDF. So DBT bought them. And why it's important. One of the biggest issues with DBT is actually the compiling and running in a way, because it's using, it's slow. For biggest projects, it creates a huge overload, which actually is not a good developer experience. Comparing it to SDF, so if they're integrating it well, it's like, my personal opinion, doesn't make sense to switch just because something fancier occurred, unless there are some other selling points that will happen. But if you want to actually build something on your legacy systems, completely suggest to use SQLGlot. And just because you actually not always it does make sense to actually for you to integrate full project to DBT, you might want to have Lineage, like not doing a full migration. So you can use SQLGlot and do manual, API maybe where you send a query and you get the dependencies extracted with column level lineage or whatnot. That was a fun example I did in one of my previous workplaces. So if you catch me afterwards, I can explain on that on the details if you want. But yeah, thank you. Any questions? Oh, yes.
Yeah, thank you for the presentation. Maybe one question,
yes.
So we're using DBT, and one particular, a problem, all the problems that you mentioned, of course, but another problem is that DBT allows you to do hacky stuff, that data flows back from your data warehouse during the compilation step to wherever DBT runs. How does SQLMesh allow something similar, or is it kind of better in a way that it doesn't allow those data flows?
You can configure actually different environments, so-called, so you can do completely different stuff. So you have your production set up to point to production server, and you can actually work locally with dev environment. And the thing is that actually if you test your changes or whatnot, it does actually async with production to development. In some cases, what's affected, if I'm not mistaken, it double checks if it's the same, if it has changed or whatnot, and then it provides you a plan actually creating, double checking if the data is correct or not, and then you can run it on your dev. If you like the changes, you can propagate the changes to the prod as well. So it allows you to do these kind of hacky things as well.
So just curious, are you running SQLMesh in production by any chance, or considering, or is it just you staying up to date with the industry?
It's just like that. Fun thing is that, my colleague, I think last week, when I was saying, yeah, I'm going to do a talk, at PyCon, and she was saying, so are we going to do a migration again? I said, no, we're not going to do that.